Hello, everyone. Welcome back to Learning with Jelly. Today is day 21 of our 30-day SQL challenge where we're going to discuss window functions. Now, for this first video on window functions, we're going to describe what window functions are, and I'm going to introduce you to one main window function called row number. Now, full disclaimer slash transparency. Window functions are very complex. It tends to be one of the hardest concepts that people learn when it comes to SQL. So I highly recommend that you look for extra practice, look for extra resources, and I will as well. But please be patient while learning window functions. If you are new to the 30-day SQL challenge, welcome. We're so happy to have you. We're going to focus on learning beginner to intermediate SQL skills so that we can hopefully land an entry level data role. You have two QR codes in front of you, and I'm going to link them in the description below. The first QR code is the topic list, which is going to have a list of all the videos as well as additional resources. And another one is our Facebook support group where you can ask questions, find a study buddy, give feedback, help troubleshoot, and more. So let's hop right into what window functions are at a high level and why we use them. Window functions are used to perform calculations across a set of rows using information from a previous row or other rows. So, say for instance, I want to create a column that is a running total. I need to know what the previous row was and that amount to know what the next row should be. So this actually retains information of individual rows in the table. It's going to return one result per row. So up until this point, if I tell you to do the average function in SQL, you're going to get out a single number based off of your group by or a single number per group. So say for instance, I want you to get the average height by gender. You're going to get two or three results where you're going to say male average height is 81 centimeters, female 74, and non-binary 76. You're going to get one result. Now, if that table had 500 people in it, instead of only giving three results back, it's going to give you 500 results. It's going to maintain that row level detail. And this is one of its many advantages. As I mentioned, it's good for running totals, moving averages. You see a lot of these calculations in finance, especially, as well as cumulative sums. It's going to retain row level detail instead of rolling things up. So, for example, say for instance, you want to see all of my purchases individually and not just a single number that represents the average of all of my purchases. And it also can help execute queries faster. When you get into the industry, there may be certain engineers or developers that are focused on making efficient code that run fast because the more time we save, the more time consumers save. So that is also very important. So let's look at this as an example. So there are two clauses that I want you to be aware of. So the over clause is going to define the window for the function to operate over. The partition by clause is going to divide the result set into partitions like little slices to apply the window function. And normally these over and partition by clauses come after some other functions, sum, average. There are going to be other window functions that it comes after, such as row number, rank, etc. But let's look at this example. I'm summing up the milliseconds. And I'm doing this over partition by album ID, meaning that I want to give this sum based off of the album ID. And as you can see, I've created this new column. I didn't roll anything up. That now is keeping a running total of the tracks within each album. So the first track was about 343,000 milliseconds. So the total was the same amount because it's the first observation. Now you can see the second track was about 205,000 milliseconds, and that total of the first and the second is 549,000. So this helps me keep a running total of all the rows in my data set, and it won't just give me a sum of just album one, sum a million milliseconds, album two, sum 2 million milliseconds, and so forth. So this over clause is going to have its own parentheses, okay? And it's going to define a window. So you're just setting a window. Now, the partition is going to know what you want to partition by, basically, what you kind of want to slice or group by, which in this case is the album ID. And we're ordering by name. And so we want the first one, the first track of an album to be the one that has alphabetical order in this case. So now let's look at two different queries and look at it against a group by. And I put a comment on each one of these. Feel free to kind of type these out, pause the video so you can actually see which each one returns. But in this case, the first one is going to return just 25 rows because I have 25 states in my data set. So I'm selecting the billing state, a sum of the total as total by state from invoices where the billing state is not null, and I'm grouping by billing state. Okay, so it's going to give me 25 rows, which is going to be the sum. So Alabama is going to have 15, California 12, etc. Whereas when I use my window function and I do my sum total now, but my over and partition by billing state instead of grouping by billing state, I'm going to give 210 rows where I may have Alabama listed 5 times, and it's going to give me the sum for Alabama 5 times. So it's going to keep the row level detail. So let's look at another example that we can compare along with the output. So say for instance, I want to return the customer ID, invoice ID, total of each invoice. So I want to retain the information. So I want to say invoice 1 was 2, invoice 3 was 5, and so forth. And I also want to get a sum of all the invoices the customer has had. So one way that you may think about doing this without knowing window functions is by standard group by. Hey, you want customer ID? Check. You want invoice ID? Check. I don't really have the total of each invoice in here, but you want a sum? Check. I did a sum for you. You want it by customer? I'm going to group by customer ID. And this is what you get. One row per customer. So customer ID 1, invoice ID 98, and the total that they spent is $39.62. However, that is the total across all of this customer's invoices, not just for invoice 98. This customer could have 10 more rows. So that would be an incorrect way of doing this. So, how can we do it the right way? And see if you notice the difference with this next slide here is that I have customer ID, check, invoice ID, check, the total of each individual invoice, check, and a running sum of all the invoices by customer. So here, instead of having one row that is just customer ID 1 with just their total and not the actual invoice amount, now I have customer ID 1, invoice 98, that was $3.98. Invoice 121, $3.96. And now I'm also getting a running total across time of how much they've actually spent up until that point. So if somebody asked you how many invoices did customer one have until they spent $30, you can easily say 1, 2, 3, 4, 5. 5 invoices until they spent a total of $30. So this gives us the row level detail that we need. So select customer ID, invoice ID. I can also return total. So instead of in my group by, I can't return total then sum of total because it's going to throw an error. But I can return total and then sum of total if I attach it to a window function. So now I'm going to do my over. How do I want to group this or partition this by? Partition it by customer ID. And I'm going to also order this by invoice. Okay, so that way it can actually give me a running total here, and I save that as a new variable. So this is the difference that you got from group by, just to drive home the point, and this is what you got from the window function. Where group by is missing a whole column because you can't keep track of the individual total amounts for every individual invoice, and it's only giving you that last result that you see for every customer, but it's not giving you that fine level detail. So a popular function that can precede window functions, because in our previous example, we used sum, right? So these are normally followed by some other type of aggregate function, sum, average, count, whatever it may be. Another function that it can precede is row number. And row number is going to assign a unique integer to rows within a partition. So in this case, I want to assign a row number for every track that exists in an album. So I'm going to select album ID, track ID, name, the function row number over partition by album ID. So that means that I want to have here my album ID 1 and 1. This was track 9 and track 10. Notice when it hits album ID 2 that it starts over counting at 1 again. Then when it hits album ID 3, it starts counting by back over again at 1. Okay? So this will give me the total number of tracks for each album, but it also will tell me what the name of that track was, as well as the track ID. So this keeps my row level detail. So row numbers are just going to assign 1, 2, 3, 4, 5, 6 based off of whatever you're partitioning by. In this case, it was album ID. So now let's hop into SQLite and actually practice this. Like I said, this is going to take some time actually practicing. In here, okay, the first thing that we have is we want to return row level info about the length of tracks and a running total of all tracks within one album. So we know we want row level info, so we're going to need some type of window function. So let's go ahead and look at this tracks table. No joins going on here. And this is all the information that we can return. We want to do length of track, so that is going to be by with milliseconds, and we also want to do a running total of milliseconds. So let's try this. Let's first select some information that we need. So we're going to need album ID. We're also going to need track ID. We can return the name of the track. We don't have to necessarily. And then milliseconds, because I want to retain the milliseconds for every individual track. Now I also want to get a sum of milliseconds because I want to get that running total piece, right? So I'm going to do my aggregate function, which is summing milliseconds, and then my over. And remember that has my parentheses. So inside my parentheses, what do I want to get a running total by? So I want to get the number of the running total of track lengths all within each album. So I want to partition by the album. So I'm going to say partition by album ID. And let's just do from track. So let's see what this gives us. No need to put no order by right now. Let's just check this out. So from tracks. So I can also return the actual variable and an aggregation of the variable if I'm pairing it with a window function. So let's see what we get. And this is what we get, okay? Where I have album ID 1, album ID 2, and so forth. But it looks like it's giving me the total, but it's not a running total. So let's figure out how we can do this. So I'm going to have to order this by something. So let's do order by name, for instance. And now I see that it's actually doing what it's supposed to. where the first value has the 263,000, the next one is not 199,000, and the total of these two values is stored right here. The total of these three values is stored right here, and so forth, all the way until the end where I got that last number that we saw in the other query. Okay. So this is how we get our nice little running total. So we do need that order by if we want to do a running total. Okay. Now, let's go ahead to our second example. We want to use the row number function to assign a number to each track in the album. And the first number that we should assign to should be the track that is the longest. So, for instance, I want to say in album one, the longest track in album one gets a one. The next longest track gets a two. The third longest track gets a three, etc., etc. So I still want to partition by album ID, but instead I want to actually just assign it a row number based off of longest to shortest album duration, track duration. So let's go ahead and select album ID. We still need that. Let's just return the same columns as above. Track ID, name, milliseconds. No shame in our game. Okay. So now our aggregate function is going to be row number, or our function, better yet, because it's not aggregating anything, is row number. And we're going to do that keyword over. And we want to partition by album ID. Okay. But how do I want to assign the rows? I want to assign the row numbers based off of the length of track, which is milliseconds. So I'm going to do order by milliseconds. And I'm going to do descending here, DESC, because I want the longest track to get the first number. And I'm going to say from tracks. And let's see what this gives me. Oops, has a lot of things going on. Let me expand this up. Let me shorten this name column so we can see. Great. So here we have track one. It has the longest milliseconds. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we start over again when we have our second album. It only has one track. And then for our third album, these are the three rows that we're looking at, with the longest track being row number ranked as row number 1, 2, and 3. So this is how this row number actually works, where we're able to actually assign a number, kind of like a rank. We're going to talk about the rank function in this case, where we can partition our data by the album and order the data by a numeric variable, in this case descending, and assign it another row number. Okay. All right. So as I mentioned, window functions are not easy. You're probably going to have to go through this multiple times, but the whole concept of window functions is that we want to maintain those rows. So we don't want to just keep rolling things up because we lose the fine detail. It helps us maintain row level detail and do calculations like running totals that we showed in this video that we can't do with other functions. So please like, comment, and subscribe. We're going to talk about window functions again tomorrow. I'm going to have the link to my Etsy and buy me a coffee in the description below. Please, please, please show support. Thank you so much. Bye-bye.